We're going to continue our lesson on alkene and alkyne nomenclature, learning some unique naming rules for when the multiple bond is inside a ring structure or when there is more than one double or triple bond in the same compound. So to start, in the same way that you can have a cyclic alkane, we can also have cyclic alkenes and alkynes. That is a ring structure that has a carbon-to-carbon double or triple bond within the ring, such as these ones shown. Now, if you took the time to fill in the hydrogens on these skeletal formulas, you might notice that they have even fewer hydrogens than their linear counterparts, which have fewer hydrogens than their alkane counterparts. So every time we make a structure cyclic or add multiple bonds, we reduce the room for hydrogens. Now, in looking at this first one, we can see it's cyclic, so we're going to use cyclo in the name, just like we do with alkanes, and that is always the part that I am most likely to forget. So we're going to have a cyclo structure. Now, then I can see that there are 5 carbons because it's a little pentagon. So the root is going to be pent. And there is only one double bond, so I'm going to have -ene as that family suffix. Now, it's important to note the following. If a ring has only one multiple bond and no substituents, locant numbers are omitted. They're not required. That's because each carbon of a ring holds an equivalent position, so the locant here is not needed. Thus, the name of this structure would be cyclopentene. Cyclo because it's in a cyclic structure, pent because it's 5, ene because there is a double bond between 2 of the carbons. Now, let's look at this next one. Here we do have substituents, so locants are going to be needed to indicate their position. Now, with cyclic structures, always assign the 2 carbons of the primary multiple bond to position 1 and 2. This is important. So, this can be carbon 1 and this carbon 2, or this can be carbon 1 and this can be carbon 2. What I don't want to do is have this be carbon 1 and then have carbon 2 be a carbon atom that is not involved in the double bond. So which is it? Which carbon should I make carbon 1? So you're going to number these 2 carbons as carbon 1 or 2, but in the direction that gives the lowest number possible to the substituents. So for example, if I start here, carbon 1, that becomes 2, 3, and 4. But if I start here, carbon 1, 2, and 3. And 3 is a lower number. So by going this direction, I get a 3 instead of a 4 on the first point of difference. And so that's the way I'm going to do it. That makes this, or these, here over here on carbon 5. And I have a total of 3 methyl groups. So tri for 3, and then methyl to indicate that they're a 1 carbon substituent group. So the final name is going to be 3,5,5 trimethyl cyclohexene. You will notice there is no interrupting locant on the cyclic structure. And that's really because it's not needed. Another chemist will be able to determine carbon 1, the location of the first carbon of the double bond, by counting away from the 3 on the substituent, so going 3, 2, 1. However, for this last one, we would need interrupting locants because we have more than one double bond, and they could be in other places, so we would need to make it clearer in the name exactly where they were. However, there are a couple other naming rules that we need to learn before we can do that. When an organic compound has more than one double bond or more than one triple bond, as we can see here, there are a few unique additions to the naming pattern. First of all, we add a prefix right here, such as di, tri, or tetra, to indicate the number of multiple bonds we're talking about, much in the same way that we use those same prefixes to indicate if we have duplicate substituents, such as dimethyl. So here in my structure, you can see that I have 2 triple bonds. So its name is going to end with di to tell me that there's 2 of them, and then yne, Y-N-E, for being an alkyne, making it a diene. Now, our second little tweak is right here. We add the letter A after the organic root for the longest carbon chain. Thus, hex becomes hexa, pent becomes penta, etc. Now, that might seem weird, and honestly, I believe it just has to do with making it easier to verbally say the name of the compound. So let's apply that here. So when I look at my skeletal structure, I see 8 carbons. Now, it can be challenging to interpret triple bonds with line formulas. You have to remember that each end of this little 3-line cluster represents 2 carbons. So in double checking, 1, 2, 3, 4, 5, 6, 7, 8. Now, 8 would be oct, which we are going to change to octa, making this structure an octadiene. However, we are going to add those interrupting locants as well to identify the first carbon of each triple bond. And so its final name will be octa-1,7-diene. Note those subtle changes to how we've been naming them are shown in red. We have that A, because we added the letter A, and we have that prefix to indicate the number of multiple bonds. Oct to indicate 8 carbons, 1 and 7 to indicate where those triple bonds are, and di to kind of reinforce, beyond just the fact that there are the 2 numbers, that we have 2 triple bonds. So going back to our previously unnamed example, we have a 6-carbon ring with a double bond, which previously we would have simply named cyclohexene. However, there's more than one double bond, so we're going to tweak that a bit. We're going to modify the ending to include a prefix indicating that we have 2 double bonds, so diene. We're also going to add the letter A to the organic root to make hex hexa, so it sounds better. So now it's cyclohexadiene. But we're also going to include those interrupting locants to identify the first carbon of each double bond, making sure that we go through both carbons in the numbering. So 1, 2, 3, 4, and I get the same numbering if I count the other way. Thus, our final name is cyclohexa-1,3-diene. Again, I encourage you to really pay attention in going back and forth between the name and the structure, as that's really the beauty of the IUPAC system, is how it tells us the structure right there in the name. Now remember, learning requires repeated practice at increasingly spaced intervals. So I'd encourage you to develop a regular habit of revisiting the material, solving problems in a similar manner to your assessments, and making sure you're returning to older content as you add new content. Good luck!